All right, today we're going somewhere extreme, to the most remote place on Earth, to find a telescope that's completely unlike anything you've ever imagined. Forget domes on mountaintops. This thing is buried a mile and a half deep, frozen solid into the Antarctic ice. And its job? To see the invisible. So that's the big question, right? How in the world do you build a telescope to see ghosts? And yeah, that's what we're diving into. Scientists actually call them ghost particles. They're these super elusive messengers from the most insane violent events in the universe. It sounds like something straight out of a movie, but I promise you, this is real science happening right now at the bottom of the world. Okay, so what are these things? They're called neutrinos. And get this, trillions of them are zipping through your body right now, this very second. They've traveled for millions, sometimes billions of years, from places like exploding stars or the chaotic edges of black holes. Now, the crazy part is, they interact with almost nothing. That makes them perfect cosmic storytellers, but it also makes them ridiculously, almost impossibly hard to catch. So if you want to catch a ghost particle, you can't just build a small trap. You need something huge. The solution they came up with was, honestly, as audacious as it was brilliant. They decided to turn a massive chunk of an entire continent, Antarctica, into one single giant particle detector. And that's what we're talking about, the IceCube Neutrino Observatory. And when I say massive, I mean the scale is just mind-boggling. We are talking about 1 cubic kilometer of solid ice. That's 1 billion tons of ice, all wired up with sensors. Just waiting for a single tiny flash of light that signals one of these elusive neutrinos has finally bumped into an atom. But why the South Pole of all places? Well, it's pretty simple actually. It's the only place on Earth that has ice this deep, this incredibly pure, and this perfectly dark. It's the ultimate silent medium. You see, on the super rare occasion a neutrino actually does hit an ice molecule, it creates another particle that, and this is wild, travels faster than light can travel through ice. This creates a faint cone of blue light, kind of like a tiny sonic boom, but with light. And because the ice is so ridiculously clear, the sensors can spot that flash from hundreds of meters away. Now, actually building this thing, the engineering was just on another level. For every single one of the 86 sensor strings, the team had to use a 5-megawatt hot water drill. Basically a giant high-tech water heater to melt a hole 2.5 kilometers straight down. Then the clock was ticking. They had only a few hours to lower this pearl necklace of 60 basketball-sized optical sensors before the hole froze solid again, locking him into the continent forever. This quote from one of the technicians just nails it. It really gets to what it must feel like to be down there. Just imagine it. You're completely isolated in the Antarctic winter, surrounded by 24-hour darkness, and you're operating the only machine on the entire planet that can see these particles from the beginning of time. It's this incredible connection between the vastness of the cosmos and just a very personal human sense of awe. Okay, so they built this incredible machine. They went through all that effort. The big question is, what has it actually shown us? Well, it's given us a completely new way of looking at our universe, a picture painted not with light, but with the ghost particles themselves. And this is a really fundamental shift in how we do astronomy. Telescopes like Hubble or the James Webb, they see photons, light. But light can get blocked by all the dust floating around in space. Neutrinos? They don't care. They fly in a perfectly straight line from wherever they were created, passing through entire galaxies like they're not even there. Which leads to this crazy fact. IceCube isn't really looking up at the sky, it's actually looking down through the entire Earth to see the sky on the other side. It uses our whole planet as a filter. So after years and years of patiently collecting data, in 2023, IceCube delivered something truly incredible, a landmark discovery. For the very first time, we got to see a picture of our own Milky Way galaxy, but it wasn't a picture made of starlight. No, it was this high-energy fog of ghost particles, a ghostly glow. This is the first ever neutrino map of our galaxy. It's almost like a shadow image, showing us where all the high-energy action is happening, stuff that's totally invisible to our regular telescopes. We are, quite literally, seeing an invisible galaxy. And because these particles travel in a perfectly straight line, never getting knocked off course, they're the ultimate tool for like cosmic forensics. For example, IceCube managed to trace a single high-energy neutrino all the way back to its source 4 billion light-years away. It came from something called a blazar, which is basically a supermassive black hole firing a jet of particles right at us. Think about that. It's like finding a cosmic bullet and being able to trace it back to the exact gun that fired it billions of years ago. But the story is far from over. In fact, a whole new chapter has just kicked off. Because as of February 2026, the first major upgrade to this detector in 15 years is officially done and installed. And man, it's been a long time coming. This whole idea was first floated by a physicist named Moisei Markov way back in 1960. It took until 2011 to get the original IceCube built, and now here we are in 2026 with this brand new upgrade. It's just an amazing testament to decades of scientific vision and just sticking with it. So what's so special about this upgrade? Well, the original IceCube was awesome at spotting those really high-energy neutrinos from way out in deep space. But these new sensors are packed together much more tightly, which means they can see lower energy neutrinos with way more precision. And that, right there, is a total game changer. It opens up a whole new frontier of physics. We can now study neutrinos made right here in our own atmosphere and even start hunting for signs of dark matter at the center of the sun. And here is the really clever part. These new sensors don't just see new things. They help scientists understand the ice itself way better, like exactly how light travels through it. So what does that mean? It means they can go back through 15 years of archived data and reanalyze all of it with this new, sharper understanding. It's just like getting a new pair of prescription glasses and looking at old photos. Suddenly, you can see details you never even knew were there. So with this new power, IceCube is leveling up. It's not just about mapping the neutrino sky anymore. Now it's ready to take a swing at some of the most fundamental, most profound mysteries in all of science. I mean, this puts IceCube right on the front lines of the biggest questions out there. Like, what if dark matter particles are crashing into each other in the center of the sun and sending out a stream of neutrinos we can finally see? What if we could finally peer inside a star at the exact moment it goes supernova before the light even gets out? Could we find a crack in the standard model, our bedrock theory of physics? These are the kinds of massive questions IceCube is now equipped to go after. And believe it or not, this is still just the beginning. Everything they're learning from the observatory and this new upgrade is basically the blueprint for the next big thing, IceCube Gen 2. It's a proposed detector that would be 8 times larger. I mean, just imagine what we could see then. Which kind of leaves us with this final amazing thought. For basically all of human history, we've studied the universe with light. That's all we had. We've just cracked open this brand new window, and one of the first things we saw was a ghost image of our own galaxy. So the real question is, if this is what we can see now, right at the beginning, what else is hiding out there in the cosmic dark just waiting for us to look?